Good morning. This is the first of two videos that I'm going to make for the 6B notes. The first video here that we're making right now is just going to go over some definitions and stuff that are going to sort of help us with proving triangles congruent. And so I wanted us to sort of have a background on these and sort of have a little bit of a foundation to sort of know what we're looking for here. Okay. So here we go. I'm going to type some of the stuff in. I'm going to write some of the stuff in just to try to keep it clean. Okay. So the first thing, the reflexive property of congruence. The reflexive property just says that something is congruent to itself. Okay, and that's pretty self-explanatory. So the reflexive property of congruence is just something being congruent to itself. Okay. So in this context, in this these two triangles right here, how this would benefit is if they share a side or share an angle. Okay, so if they have a shared side, and or angle, okay, we can use the reflexive property of congruence. So here, for instance, these two triangles, RST and UST, they share that side ST. Okay, so since they share that side ST, we could say by the reflexive property of congruence that ST is congruent to ST. Okay, kind of obvious, but when we make our proofs, we still need to be able to document that down and prove that as we go through our two column proofs, which we're going to look at the structure of those things in the second video. So right now, I just want to give you guys these definitions here and the context of these definitions in terms of proof. So that's a reflexive property of congruence. Okay. Vertical angle theorem. We talked about this very, very early on here. And so the vertical angle theorem is just two non-adjacent angles at an intersection are congruent. It should be an intersection of two lines. Right, so two non-adjacent angles at the intersection of two lines are congruent right there. Okay, and we talked about that very early on in the year as well. So what we have here is that we have these two lines, QT and PS. Okay, they're parts of these triangles, but they're also two kind of longer lines that intersect each other. And so we have a pair of vertical angles right there. So with that, we could say, okay, angle QRP is congruent to angle SRT. Okay, so angle QRP is congruent to SRT because of the vertical angle theorem. Okay, the vertical angle theorem says that vertical angles are congruent to each other. Okay. All right. So that's that. Let's move on to the next thing here. Again, pause the video if you need to. Go back and rewind it as you need to. Again, I'm trying to go, as quickly as I can here. So if you need to slow it down a little bit, that's on you. All right. I'm going to go ahead and erase some of this stuff up here just to give myself a little bit more room. Okay. Our next thing we have is midpoint. Okay. So the midpoint is, it's pretty obvious, it's a point in the middle. It's a point in the middle. So that's, but a more proper definition would be point on a line segment equidistant from the endpoints. Okay, so it's the point is in the middle. Okay, so that would be our definition of midpoint there. A little bit smaller. Yeah, apologize for that. Trying to midpoint. It's a point on a line segment equidistant from the endpoints. Okay, the point is in the middle. So let's just say hypothetically here, all right, in terms of the constants, let's say they tell us. Let's say they tell us right here that R is the midpoint of PS or something like that. Okay, let's say they give us that. It's given that R is a midpoint of PS. Okay, so if they give us this information that R is a midpoint of PS, okay, well, R is a midpoint of PS. So what that can tell us is, okay, PR and RS are congruent to each other. Okay, so in context of that, we could say, you know, given this information, we could say segment PR is congruent to segment RS, okay, by the definition of midpoint. Okay, by the definition of midpoint, they tell us that R is a midpoint, so PR is equal to RS. PR is congruent to RS because that's what a midpoint does. Moving on. Bisect are in line segments. Very similar to midpoint here. All right. So we all know that bisect. Okay, bisect just means to cut in half. Okay, or divide into two. Okay, to divide into two congruent parts. This is really just a cut in half. Okay, that's a straight definition. So a point can bisect something, or a line segment can bisect. So let's say we have a line segment that gets bisected here. Okay, so let's say in this triangle right here, they give us that PS bisects QT. Okay, let's say they give us that PS, this line segment right here, bisects QT. All right, now with that happening here, QT is being bisected. Okay, QT is being bisected, so QT is getting cut in half. Okay, so if they give us that PS bisects QT, we can assume, or we can state for a fact that QR is congruent to RT. Okay, by the definition of bisect. Okay, we know that that bisect means to cut in half, to divide into two congruent pieces. So if the information is given to us that PS, this segment here, bisects QT, in other words, PS is a knife that is cutting QT in half, then QR is congruent to RT. Okay. Now, coming up to our next thing, sides can get bisected. Well, angles can also get bisected. So, angles, again, an angle is just that's getting bisected is getting cut in half. Okay, so to divide into two congruent pieces. Okay, so I'm not going to redo the definition of bisect up here, but let's say they give us down here something like TS. Say TS bisects angle RSU. Okay, so if they give us that TS bisects angle RSU, okay, we'll look at angle RSU. So angle RSU is that big angle right there. Okay, TS cuts it in half. So now I have two little congruent pieces, RST, UST. All right, so I can say angle RST is congruent to angle UST, again, by the definition of bisect, okay? Bisect, by definition, is to cut into two equal pieces, or cut in half. All right. Next, perpendicular and right angle theorem. Again, these are two kind of different things, but I'm going to sort of merge them into one just to save ourselves some time. So, you know, lines being perpendicular. I'm trying to pull this up here. Computer's being a jerk today. All right. Lines are perpendicular. They intersect at 90 degrees. Okay. Creating right angles. Okay. And the second part of the right angle theorem is all right angles. Again, very obvious. We all know that right angles are 90 degrees, but it's still something that we need to make sure that we write down when we do these proofs, okay? So let's say we're looking at this thing here, and this says ST is perpendicular. And also, perpendicular, the symbol for perpendicular is like an upside down T. I'll sort of draw that up here. So if they say ST is perpendicular to RU, and my computer's freezing up. Here we go. So if they say ST is perpendicular to RU, the symbol for perpendicular is this little upside down T. Okay. So if ST is perpendicular to RU, geez. All right, we can say that angle RST, angle, check that, not RST, angle RTS, excuse me. Angle RTS and angle UTS are right angles, okay, by the definition of perpendicular, okay? So the definition of perpendicular can make these things right angles, and then the right angle theorem can further tell us that angle RTS is congruent to angle UTS. Again, a lot of common sense stuff right there, but it's still good to learn how to write all this stuff down and to document all this stuff here. Okay. Two more of these bad boys to go, and then that'll be the end of this video. All right, next up, we have the definition of congruence. Okay, definition of congruence is just if they give us two equal lengths. So if we have things that have equal lengths or equal measures, then they are congruent. Again, fairly obvious. That's why I'm not going to write anything for definition of congruence. It's just if things have the same measurement, then they're congruent. Okay. So let's say, I don't know, they give us something here, whereas segment RS equals 8 inches, and segment SU equals 8 inches. So let's say they give us that information. So that's 8, and that's 8. Okay. Well, by the definition of congruence, we could say, okay, well, RS is congruent to SU. By the definition of congruence. Because congruence is defined as having the exact same measurements, okay, which if RS has a length of 8 inches and SU has a length of 8 inches, then they have the same measurement, okay? So that is sort of the definition of congruence. Last thing I want to talk about here as I erase some of the stuff, again, pause if you need to, is alternate interior angle theorem. Now, this goes back to, you know, what we did, I think it was in unit 3 or 4. Maybe it might have even been in unit 2 with the parallel lines and the transversals and all that. That was unit 4 right before Christmas. That's right. So alternate interior angle theorem is going to tell us that this may not be the only one. This is the one we're going to see the most. Okay. So two lines are parallel by a transversal. And alternate interior angles are congruent. Okay. So two lines are parallel and they're cut by a transversal, then alternate interior angles are. I'm trying to make this a little bit neater here. So how this would look here is this. Let's say, hypothetically, we're trying to prove these two triangles congruent ABD and CDB here. And let's say this side is parallel to that side right there. Okay, so we have BC being parallel to AD, and let's say they give us that. So they give us, so they give us that BC is parallel to AD, something like that. Okay, what we see is, so BC is parallel to AD, right? Now BD is a transversal that cuts through that. Okay, well, what happens is we have a pair of alternate interior angles here, angle CBD, okay, and angle ADB down there, okay? So what that kind of proves is we can say, okay, angle CBD is congruent to angle ADB, okay? So this angle is congruent to that angle because, again, they are alternate interior angles, okay? They're in a triangle, but they're still alternate interior angles because those two sides being parallel, BC and AD, give that away, okay? We can go back to, I believe it was the 4B notes that talk about that, okay? So it could be something like this where they share a side, or it could also be something like in this triangle right here. So I have another example here. Let's just say that QP is congruent to ST. So if QP is congruent to ST, we have, or not congruent, excuse me, parallel. So if QP is parallel to ST, all right, what we have is, okay, we have really two transversals. So we have this green transversal right here. We also have this transversal right there, okay? And now what happens is this angle Q is alternate interior to angle T, all right? And this angle P is alternate interior up here to angle S, okay? So if these two lines are parallel, we can make P congruent to S, and we can make Q congruent to T by the alternate interior angle theorem right there, okay? So in conclusion, these first 2 pages of these 6B notes are just some definitions for you guys. A lot of these definitions we already know, but I'm trying to put them into context of congruent triangles and proving triangles congruent, all right? And so hopefully on the next page, these 6B notes, we can put this stuff a little bit together a little bit more, okay? So that's that. Go back and rewatch the video if you need to, and please ask me any questions as you need. Thank you.